Hi everyone, welcome to the session of CMC, Cellular Mobile Communication. In this class, we will learn about the dropped call rate and their evaluation. So in previous session, we have completed the topics, that is one is MAHO, the mobile assisted handoff, and second one is inter-system handoff. What is MAHO, what is inter-system handoff? So those topics we have covered in previous session. Now we will see as well as vehicle locating methods also. So now we will see the dropped call rate. What is meant by dropped call rate? That is the definition of dropped call rate and consideration of dropped call rate and the formula for the dropped call rate. So we will see these topics in this session. So the definition of dropped call rate is after the call is established but before it is properly terminated. So the definition of call is established means that the call is set up completely by the setup channel. So call is established means the call is set up completely by the setup channel. If there is a possibility of call drop due to no available voice channels, this is counted as blocked call, not a dropped call. So let us consider we have a mobile unit and we are making a call. So whenever we are, that is one subscriber take a call and that means the subscriber makes a call to another person. Okay, so whenever there is some setup channel, free setup channel or voice channel, then that channel will be allocated to that person in order to communicate with the other person. That is call is established. Call is established means call is set up by the setup channel. Okay, so when call is established but it is not properly terminated, that is middle of the call, it is dropped. Okay, so that is called dropped call. So if there is a possibility of dropped call due to no available voice channels, then that is called blocked call. That is not a dropped call. So here this is that means what is meant by blocked call. That this point says that if there is a possibility of call drop due to no available voice channels. If there is no available voice channel, then automatically call is blocked. Call is blocked. That call is known as blocked call, and that is not a dropped call. So dropped call means when call is established but it is not properly terminated. Okay, so that is called dropped call. So if there is a possibility that a call will drop due to the poor signal of the assigned voice channel, this is called dropped call, or this is considered as dropped call. What is meant by dropped call? So here the call is established and there is a possibility that a call will be dropped due to the poor signal strength of the assigned voice channel. That means if we have some, that means we are allocated by some voice channel, but the voice channel strength is very low. Because of poor signal of voice channel, assigned voice channel, the call will be dropped. Okay, so that type of call is known as dropped call. After the call establishment, it is not properly terminated because of the poor signal strength of the voice channel. Okay, so that is the definition of dropped call. So this case can happen. That means it can happen when the mobile or the portable units are at the standstill and the radio carrier is changed from a strong setup channel to weak voice. So this is happened when our mobile unit or at a standstill. So that means our mobile unit is working properly. There is no problem in our mobile unit, but the carrier signal is changed from strong setup channel to weak voice channel due to fading, due to frequency fading. Due to frequency fading, the strong channel will be converted to weak channel. So whenever the channel becomes weak, then automatically call is dropped. Okay. So here the mobile unit is working properly, but because of the poor signal strength of the voice channel, the call is dropped. And this poor signal can occur because of the fading or frequency fading. So here we have the points, that is the perception of dropped call rate by the subscribers can be higher due to because of all these reasons. Subscribers means weak. Okay. So what is the perception of dropped call rate? In our perception, we can think that these are the reasons of dropped call rate. Okay. So what is our perception? Means first is the subscriber unit not functioning properly. So we can think that our mobile unit is not functioning properly. It needs some repair. Okay, that means if you have some dropped call, that means our call is terminated at the middle of the call. Then we can think that our mobile unit is not functioning properly and it needs some repair. And the second reason is the user operating the portable unit or the mobile unit in the vehicle. That means we are in the vehicle. Then we can think that this is the problem. That is the second point. And third point is the user not knowing how to get the best reception from the mobile unit or portable unit. So if the user not knowing how to get the best reception signal from a portable unit, and they may think that they need some education in order to get some better reception level. Okay, so these are the perception views of subscribers. First one is the subscriber unit needs some repair, and second one is it is in the vehicle. Next, third one is they may think that they need some education. So these are the perception views of subscribers. And next one is consideration of dropped calls. So in order to calculate the dropped call rate, here we have to consider some more points. Okay, so always the dropped call rate should be minimum. Always the dropped call rate should be minimum. So what is the dropped call rate? We have to find out that value. So in order to find out the dropped call rate, we are considering the following parameters. So in principle, the dropped call rate can be set very low if you do not need to maintain the voice quality. So if we do not need better voice quality, if we do not need to maintain some voice quality level, then we can get some low dropped call rate. What is meant by voice quality? That is the level of the speech signal. Okay, in first chapter we have already covered there are 5 levels, CM1 to CM5. So CM5, CM1, CM2, CM3, CM4, CM5. So that is voice quality, excellent, good or poor. So depending on that level, we can say that the voice quality is good or bad. Okay. So here, if we do not need much voice quality, if we do not need some required voice quality level, then we can automatically lower the dropped call. Okay, so that means there is a relation between the voice quality and the dropped call rate. So the dropped call rate and the specified voice quality level are inversely proportional to each other. So in designing a commercial system or cellular system, we have some specified level of voice quality. The specified voice quality level is given relating to how much C/I value it can tolerate. So for every commercial system, for every cellular system, there is some level of voice quality. Okay, so the voice quality level depends on the C/I value. That means how much it can tolerate. So depending on the C/I value, there is some voice quality level. If we do not maintain that voice quality, then automatically we can lower the dropped call. Okay. So there is a relation between the dropped call rate and the voice quality and the C/I value. Okay. So by maintaining certain voice quality level, the dropped call rate can be calculated by taking the following factors or considerations. Okay. So these are some considerations in order to find out the dropped call rate, and the dropped call rate depends on the voice quality as well as C/I value. So voice quality obviously depends on the C/I value. If we have some more interference, voice quality is very low. If we have some less interference, then the voice quality is very high. Next. So here considerations are, in order to calculate the dropped call rate, we have to consider these parameters. First one, provide signal coverage based on the percentage that all the received signal will be above a given signal level. So we know we cannot provide 100% coverage for any area. We cannot provide the communication to 100% area. Okay. If you take some flat terrain, we can provide the quality or we can provide the communication up to 90% of the area. Okay. And this is the case of flat terrain. In case of hilly terrain, that may be 75 or 70 to 75 range. Okay. So that is the percentage we can allocate the coverage through that is to that particular area. So here let us consider there is some flat terrain and we are providing the signal coverage up to 90%. Okay, and we are maintaining some specified co-channel and adjacent channel interference in each cell during the busy hour. During the busy hour means in the morning time or at the night time, there are some busy hours. That means at that point of time, the mobile units are busy and the channels are also busy. Okay, that is the worst interference case. That means at that time we can get some more interference. So these are the considerations in that particular time. Okay, and maintain some co-channel and adjacent channel interference levels. We are maintaining some co-channel interference level as well as adjacent channel interference level. That means for voice quality we are maintaining some level. For C by value also we are maintaining some particular level. Okay, so if that level is decreased, that means the voice quality is very low. If C by value decrease means there is some more interference. Okay, we have to maintain that value. We have to maintain that level. So here we are maintaining co-channel and adjacent channel interference levels also during the busy hour. And next, third consideration is the response time of the handoff in the network will be the factor that is when the cell becomes small. So the response time for a handoff request has to be shorter in order to reduce the call drop rate. So response time means from mobile unit to the cell site. Mobile unit sends the signal and cell site sends the signal to the mobile unit, and from the mobile unit, the signal which is appeared at the cell site, that is within the particular time, that is called the response time. So the response time of the handoff should be low. So the response time of the handoff request has to be shorter, should be low in order to reduce the call drop rate. So if the response time is very high, there may be a chance of dropped call. Okay. So that's why in order to avoid the dropped call, the response time for the handoff, that is from mobile unit to the cell site, should be low. That is, it should be responded. The mobile unit should be responded properly within the time for the cell site. If it is not properly responded within the particular time or within the response time, then automatically call will be dropped. Okay. So that is the third consideration. And fourth consideration is the signaling of handoff and the MAHO algorithm will also affect the call drop rate. So call drop rate also affected by the signaling of handoff. That is, what is the signaling of? Signaling of handoff means if other channels are free, then it will be allocated earlier. If other channels are busy, then it will be lower. So dropped call rates depends on the signaling of handoff as well as MAHO algorithm. What is MAHO? Mobile assisted handoff. That means mobile unit automatically sends a request to the MPSO, and depends on that request, it will be assigned. Handoff call will be assigned to that particular mobile unit. So this topic already covered in previous session. Just go through it. So signaling of handoff and MAHO algorithm also affects the dropped call rate. So these are the considerations we have to follow whenever we are considering or we are calculating the dropped call rate. Okay. So here this is the relation. So here the relation is between the capacity and the voice quality and dropped call rate. Okay. So the capacity M is expressed as, here the capacity is represented as small m. So radio capacity small m is equal to Bt by Bc by square root of 2 by 3 into C by I of S. What is Bt by Bc? Bt by Bc is number of voice channels. Number of voice channels in that particular cell. And that is the given number. And C by S is the required C by. Here C by of S is a required C by for designing a system. Okay. So this is the minimum C by value in order to get some better voice quality. Okay. So the above equation is obtained based on 6 co-channel interference which occur in busy channel. So this is the equation which is calculated at the time of busy hour. At the time of busy hour, and we are considering we have some 6 co-channel interference. That is 7 cell reduced system. We have 6 co-channel interference, and this is the this is the equation which represents or which is calculated at the time of busy hours. Okay. And next, this is simplified. This equation is simplified. That is, here we are calculating C by I of S. So from this equation, what is C by I of S? C by I of S is equal to 3 by 2 is into Bt by Bc by M whole square, or 3 by 2 into Bt by Bc whole square into 1 by M square. So this is the simplified equation from this equation. So from this equation, we are calculating the required C by I value. Required C by I value. So because the C by I is a required C by I for designing the system, the voice quality is based on the CBI value. Already we know. Depending on the CBI value, there is voice quality. If interference is more, voice quality is less. If interference is less, voice quality is more. Okay. So when the measured CBI is less than the specified CBI or the required CBI, we have some poor voice quality and we have some dropped calls also. So when we are measuring the CBI value practically in that particular area and we are maintaining some required value of CBI, if the measured value in that particular area is less than our required value, then automatically what happens? If CBI, our measured CBI is less than the required CBI, means we have some low voice quality, poor voice quality. Obviously, dropped calls can also occur. Okay. So this is the equation which represents the voice quality as well as the dropped call rate. Depending on its required CBI value, we can calculate the voice quality, and depending on the voice quality, we can also calculate the dropped call rate. Okay. So these are all interrelated to each other. So next one is general formula of dropped call rate. What is the general formula? Okay, so this is the formula in terms of probability. So the general formula of dropped call rate, that is represented as P in the system. So that is equal to 1 minus summation n is equal to capital N alpha n x power n, and that is the that can also be written as summation n is equal to 0 to capital N alpha n Pn. That is equal to alpha n into Pn, where Pn is 1 minus x power n. Pn is 1 minus x power n, where Pn is the probability of dropped call rate. Probability of dropped call rate when n number of handoffs. Okay, what is x here? So x is in terms of del, mu, and theta and beta. Okay, so x is equal to 1 minus del, 1 minus mu, 1 minus theta v, 1 minus beta whole square. So x depends on del, mu, theta and beta. So these are all probabilities which we will discuss here. So first one is del. What is meant by del? So del is the probability that the signal is below the specified threshold level. Already we know we are maintaining some threshold level. If the received signal strength is greater than that threshold level, then the signal is okay. Then if it is less than threshold level, then the signal is poor. Okay, so here the del is the probability. It represents the probability that the signal is below the specified threshold level. So how much level the signal is below the threshold level, that is represented in terms of probability, that is del. Okay, and next mu. Mu is the probability that the signal below the specified Coachon interference level. So this is the term which represents the probability that the signal is below the specified CBI value or required CBI value. Okay, so already we know handoff depends on CBI value and signal strength also. Similarly, the dropped call also depends on CBI value and voice quality. Okay, so what is the voice quality? What is the probability? Then that will be measured by the del. And what is the probability of CBI? That is, the area is up to the required CBI value or it is less than required CBI value. That will be considered or that will be measured in terms of probability by the value of mu. Okay, so this is the probability that the signal is below the required threshold level, and this is the probability that the signal is below the Coachon interference level. Okay, if it is below the Coachon interference means that is we have some more dropped call rates, and in this case also. Okay, so how much we can get the signal and how much we have some Coachon interference. So those two values can be calculated by the use of del and mu in terms of probability. Next, tau. Tau is the probability that no trophic channel is available upon handoff attempt when moving into a new cell. So tau means what is the probability if we have no channels, no available channels in the neighboring cell. Okay, so tau represents the probability that no trophic channel, that is no available channel in the neighboring cell or in the available cell when handoff attempt takes place. Okay, that is when our mobile unit moves from one location to another location. It needs some handoff and it attempts some handoff. And if there are no available channels in the particular neighboring cell, Then what is the probability? That probability is calculated by the value of tau. And theta is the probability that the call will return to the original set. At what probability the call will again return to the original set? That is the home set. Okay, that is represented by the theta. And beta is the probability of blocking circuits between MSC and BSC during handoff. So whenever there is handoff means there is some blocking circuit. So there are some blocking circuits between BSC and MSC. That is base station and MSC. That is BSC and MSC. We have some blocking circuits during the handoff. And what is the probability of those blocking circuits? That will be calculated by the beta. And alpha n is the weighted value of those calls having n number of handoffs. So alpha n represents the value when we have n number of handoffs, weighted value when we have n number of handoffs. So we have also formula here. So this formula represents the alpha n value. Okay, that is summation n is equal to 0 to n, alpha n is equal to 1. That is the summation. If you sum all the handoff calls, then that is equal to 1. So alpha n is the weighted value of those calls, handoff calls. And next, n is the highest number of handoffs for those calls. What is the highest number? Handoff. That is, what is the highest number of handoff calls in that particular cell? That will be indicated by the n. So capital N is the highest number of handoffs in that particular cells. Okay. So these are all comes under evaluation of dropped calls. Okay. So here first one is definition of dropped call. What is meant by dropped call? What is the difference between blocked call and dropped call? Blocked call means the call is blocked if there are no available channels. Dropped call means some voice channel is assigned to that particular mobile unit, but because of the poor signal strength of voice channel, the call is dropped at the middle of call. Okay, so that is called dropped call. So it is that is the call is dropped depending on the voice channel. If you have some poor voice channel, call is dropped, and that is depends on the fading. If you have some fading, call is automatically dropped. So dropped. So we have some perception, that is in the view of subscribers. What is the perception of dropped call rate? So these are the three perception views of subscribers. And next one is to calculate the dropped call. What are the considerations we have to follow? Always the dropped call should be low. So that means there is a relation between the voice quality and dropped call rate. And obviously the voice quality depends on the C by value. Depending on the interference, we can get the voice quality. So these three parameters are interrelated to each other, and the relation between those three parameters are given in this formula. So here we are considering these parameters in order to calculate this value. Okay. So first one, we are providing 90%. We are providing 90% coverage to the cell, and we are maintaining some co-channel and adjacent channel interference levels, and we are maintaining some response time, and we are also calculating the signaling of handoff and MAHO if there is any MAHO algorithm. So these are all considerations we are following, and we are calculating the radio capacity M value. And this depends on the voice channel, that is VT by BS and C by value. This is the required C by value. So here the required C by value, if our measured value in that particular area, if our C by value is less than that required C by value, then automatically voice quality is, if voice quality is poor, automatically dropped calls can happen. Okay, that is minimum number of dropped calls. That is the point. If you have some better voice quality. So next, general formula for dropped call rate. This is the formula in terms of probability. Dropped call rate in terms of probability, and here we have Pn is equal to 1 by x power n. X depends on these parameters. So that is del, mu, tau, beta, and theta, alpha. So these are the terms which we have to remember when we are calculating x value or probability of dropping. Okay, so thank you.